This is tutorial video 3, part 2, with regards to finite element analysis of plane stress structures. We are still be looking at the preprocessor stage. We'll be defining the materials, boundary conditions and loading of a glass plate connection. The geometry was given in the previous video and we discussed the geometry and some of the boundary conditions. So we started the model, and the geometry, we created an opening in the mesh, we created a group called circle, and now we need to start defining material properties. So we go to define material, we add a new material which we're going to call glass, and again we can change the properties, the self-weight or any other properties. So for example, if we put a 50 kilonewtons cubic meter of density, if we had for the self-weight, in this case we are not considering the self-weight, we are only looking at this tensile force on the right hand side of the plate. So the main parameters, material parameters that we need to focus on plane stress is the Young modulus and the Poisson ratio. So if we put in the units in newtons millimeter, that will give us megapascals. So we said that the material has 72,000 megapascals, so 72,000, and the Poisson ratio is 0.1. The other parameters we don't need because we are running just an elastic analysis. So once we define the material, we need to define the section properties or the physical properties, and we go to area sections. Now we want to use plane stress elements, so we come to plane here and we add a new section which we're going to call plane. So it's a plane stress element, and we can change the material to glass, and the thickness you have in millimeters is 10 millimeters. So we need to assign these properties to these elements here. So we select all of the elements and then we go to assign, area, sections, and we assign plane elements. So if we zoom in, we can see that all the elements are plane. You can click on them and right click and you will see that it has the properties of the plane element. You can also check in 3D whether the thickness of the elements makes sense. So we go to view options and we say fill objects and extrude view. We can see that the thickness of the elements seems reasonable, and we can check general things about the model. So now we have defined the materials, we need to define the boundary conditions. So as we discussed in the previous video, for the edges which are connected to the rest of the plate, these are planes of symmetry. So the degrees of freedom in a plane stress element, which is the horizontal and vertical displacement, in this case for the nodes in the plane of symmetry, the perpendicular deflections will be equal to 0. So in this case uz will be equal to 0. So we'll go to assign, joint, restraint, and in this case we need to say is u3 equal to 0. Now in the manual, if you look for plane stress problems in SAP 2000, it also says that you have to set up the perpendicular to the screen deflection to equal to 0 as well. You need to activate that degree of freedom, although in a plane stress problem this is not taken into account. So these are the boundary conditions for the edges. Now we need to apply the boundary conditions for the plate, for the circle. So in this case, in this connection, we can assume that it's fully clamped, so the nodes along this perimeter will be fixed. Basically, it will not be moving. So we go to select group. So we select the nodes at the circle, and we assign joint restraints. And in this case we set up all the displacements equal to 0. Again, we don't deal with the rotations because this is a plane stress problem, so the rotations are not active degrees of freedom. So now we have the boundary conditions, we need to assign the loads. So first of all, we need to define a load pattern for the live loads. Live, type of load, live load. So it has a self-weight multiplier for the dead load equal to 0, and we add this load pattern. So what we introduce now is a surface pressure on this side of the structure. There are many different ways of doing this. We can apply nodal loads, or you can apply a surface pressure. So if you go to select the elements first, if you go to assign, area loads, and you go to surface pressure, which is valid for all kinds of elements, and you apply the load to the live load pattern. In this case, we look at the loading. It's at 200 kilonewton per meter along this side, which is 200 kilonewton per meter divided by 10 millimeters gives you 20 megapascals. So it's a pressure of 20 megapascals because it's in compression, sorry, it's in tension, so it will be negative. And then it's applied to different faces. You can apply to the top, bottom, but it's applied to this edge, which is here. This depends on the definition of the element, depends on the local axis and the labeling of the nodes of the element. So for example, if we look at phase 1 and we apply the load there, you can see that for all of these elements here, phase 1 is this phase, which is where we want to apply the load. So you can see also that the loads, they are correctly, they have the right direction. And the only problem we have is with the node here, with the element here on the top, which has the phase 1 is here and not there, so we need to change the load for this particular element. If you want to see the local axis again, you can view the local axis. If you want to view the nodes, you can view it here. And if you have questions about which phase is which, phase 1, phase 2, the best thing is to go to the manual, go to help, documentation, and you can find the definition of the phases. Now we can see that the only force we need to change is the one in this element. So we can go to there and assign area load, surface pressure, and in this particular element it will be phase 4. So you can see that now all the loads are applied correctly. If you have questions about this, you can go to display, show load assigns and area loads. And for example, you can say, you can view the loads applied on phase 1, which are here, and you can show the loads applied on phase 4, which are there. And all of these have values of 20 megapascals. So these are the loads, and now we can run the analysis. So we will set up first the degrees of freedom. So if we go to analyze, set analysis options, we only have to analyze, in theory, UX and UZ. Okay, we don't analyze the rotations. Now if you go to the manual, it says that you have to activate UY, which is the deflection perpendicular to the screen. For a plane stress problem, this degree of freedom actually is not taken into account, but for this software we have to activate it anyway. So now we have defined the geometry, defined the material, defined the physical properties, defined the boundary conditions and the loading. We are ready to run the analysis.